Good day, friends and viewers. Welcome to Passwell Science Channel. Today, we are going to be looking at NACO 2022 qualitative or SALT analysis. And as you know, this year we are given two simple salts to analyze. The first one, sample X, is zinc carbonate, while the other one, the sample Y, is aluminum chloride. So I hope you enjoyed the video. Please do like and subscribe to our channel, Passwell Science Channel. God bless you all. Happy watching. All right, welcome back. As you can see, this is a NACO 2022 chemistry practical qualitative analysis. So we have here sample X. The question says X is a simple inorganic salt. Carry out the following test on X. A. Put all of X in a test tube and add dilute hydrochloric acid and test the gas evolved, if any, with litmus. B. Divide X into two portions. Roman numeral 1. To the first portion, add dilute sodium hydroxide solution in drops, then in excess. 2. To the second portion, add dilute ammonia solution in drops and in excess. Now the optional question there is that you can have a test sample to which you add barium chloride solution followed by dilute hydrochloric acid. Alright, so let's get right into the analysis. Alright, so as is expected, you are going to prepare a table of observation for this particular analysis, and that will consist of three columns. We have the test, the observation, and then the inference. Now A says, put all of X in a test tube and add dilute HCl and test the gas evolved, if any, with litmus. So I come to my observation table. I say X solid plus dilute hydrochloric acid, and when you add dilute hydrochloric acid to salt X, the observation is that effervescence occurs, full stop. A colorless, odorless gas is evolved, which turns blue litmus paper red and turns lime water milky. So that will be your observation. And then the inference will be that the gas is acidic. Gas is carbon 4 oxide from carbonate ion or hydrogen carbonate ion present. Alright, the B part says divide X into two portions. Number 1, to the first portion, add dilute sodium hydroxide solution in drops, then in excess. So I come to my observation table. BI, first portion of S aqueous plus dilute sodium hydroxide solution in drops. And what is my observation? White gelatinous precipitate is formed in drops. The inference is that zinc ion, aluminum ion, or lead 2 ion are present. And then plus dilute sodium hydroxide in excess, the white precipitate dissolves or is soluble in excess sodium hydroxide solution. And then the inference is just still the same: zinc ion, aluminum ion, or lead 2 ion present. Alright, so we now go to the second part of the question. BII says to the second portion, add dilute ammonia solution in drops and in excess. So we go back to our observation table. BII, second portion of X aqueous plus dilute ammonia solution in drops, and the observation is that white gelatinous precipitate is formed, and then the inference is that zinc ion, aluminum ion or lead-2 ion present, and then plus dilute ammonia solution in excess, white precipitate dissolves or is soluble in excess ammonia solution, and then the inference will be that zinc ion is present or is confirmed. All right, so that brings us to the end of analysis of sample X, which is what we have done. All right, the second sort we shall be analyzing is salt Y, which is also a simple inorganic salt. Question says, why is a simple inorganic salt? Carry out the following test on Y. A. Put all of Y in a test tube and add 10 cm³ of distilled water. Stir and test with litmus paper. B. Divide Y into 4 portions. Roman numeral 1. To the first portion, add dilute sodium hydroxide solution in drops and in excess. 2. To the second portion, add dilute ammonia solution in drops and in excess. 3. To the third portion, add few drops of dilute hydrochloric acid. 4. To the fourth portion, add few drops of dilute HNO3, that is triosonitrate 5 acid, followed by silver nitrate solution and dilute ammonia solution. Alright, so let's get right to the analysis. Okay, as usual, we have our table of observation with 3 columns. So here we have the test, and then the observation, and here we have the inference. So A, so we have Y solid plus 10 cm³ of distilled water. When we do that, we are going to have that Y dissolves to give a clear solution. So what is the inference? Y is a soluble salt. Any salt that dissolves to give a clear solution is a soluble salt. Alright, then plus litmus. So we can use both blue and red litmus. With red litmus, you are not going to observe any change. There's going to be no effect. But then with blue litmus, we have that solution of white turns blue litmus paper red. And what will be the inference? The inference is that solution of Y is acidic. Solution of Y is acidic. Alright, so we go to the B part of the question now. Say first portion of Y aqueous plus dilute sodium hydroxide aqueous in drops. What is the observation? White gelatinous precipitate will be formed, and the observation will be that zinc ion, aluminum ion, and lead or lead-2 ion present, and then plus dilute sodium hydroxide in excess. When we now add in excess, we have that white precipitate is soluble in excess sodium hydroxide solution. The inference will still remain the same: zinc ion, aluminum ion, or lead-2 ion present. And then we move over to the B now. BII. To the second portion of Y, we add dilute ammonia solution in drops. Alright, we also have as observation white gelatinous precipitate will be formed, meaning that zinc ion, aluminium ion, or lead-2 ion present, and then plus dilute ammonia solution in excess, and we will have that the white precipitate will remain insoluble in excess ammonia solution. It will not dissolve in excess ammonia solution. So the inference now will be that what aluminium ion or lead-2 ion present, because zinc will always dissolve in excess aqueous ammonia solution. So that has eliminated the possibility of having zinc in the sample of salt Y. All right, then we move on to the next, which is BIII. BIII says to the third portion of Y plus dilute hydrochloric acid. And when we add dilute hydrochloric acid to solution of Y, there will be no visible change. No visible change or reaction will take place. And the inference is that aluminium ion is confirmed, because aluminium does not form any precipitate with aqueous ammonia, whether in drops or in excess. Does not form any precipitate with dilute hydrochloric acid. And then finally, to the B4, to the fourth portion of Y aqueous, we add HNO3, that is triisonitrate 5 acid, followed by silver nitrate solution. And then the inference, the observation will be that a white precipitate is formed. So that white precipitate means that either chloride ion, bromide ion, or iodide ion are present. And for us to be actually sure which of them is present, we now add ammonia solution in excess. And when we do that, the white precipitate is going to dissolve in excess ammonia solution. So when we add excess ammonia solution to the white precipitate formed, if it dissolves, the inference there is that chloride ion is confirmed, because it is only chloride ion that dissolves in excess aqueous ammonia. All right, so that is that for the salt analysis. Remember that for the sample X, you can also be asked to heat the solid salt, and when you do that, you are going to obtain a residue which is going to be yellow when hot, but white when cold or cooled. All right, so that may also be added to the test. Okay, thank you very much for your time.